All right, so remember how we said the domain is the x values and the range is the y values? I hope I made that clear in our initial notes. Remember how we were talking about this mapping notation? You have a number x over here, like we sell 20 cookies, I think it was, or something. And then we made, I can't remember, like $195, let's say. Okay, so how does that, what does that mean as far as domain and range? Well, if this is my x and this is my y, this is my independent variable, this is my dependent variable, this is the domain and this is the range, okay? So in the domain, we have 3, -7, 7, 3. That's it. That's all we got to say is it's the set of numbers. Sometimes they put these curly brackets around it, and then we list it like so. You just put all the x values down. Now, do you notice how there's two x values listed here that are the same? You don't really need to list them twice, but I'm pointing that out because that is going to be a problem. When you have an x value that has two different y values, so at one point it's 7, okay, and at another time it is 15, we were saying in a business, that leads to problems when you have a function that's generating two different numbers. Are we going to make $15 or are we going to make $7? And, why are there two different amounts that we're going to make if we sell 3 cookies? Well, fraud or poor business practice or something like that, right? It causes confusion. So this one would not be a function, not a function. And it's because we have repeated x values with two different y values, right? And I haven't listed my range yet. You do the same thing with the range. Let's see, we got 7 is one of the y values, and 9 and 15 is two other y values. So notice I didn't list the two 7s twice. The only reason I listed 3 twice is just to point out that that's a problem when you have two of the same x values going to two different y values. Hope you do okay on problem number 1. I think they'll probably not count it if you list the 3 twice, so don't do that in your little curly brackets. Determine whether the equation defines y as a function of x. Okay, that means y is, all by itself and that it's a function, right? So right now, I don't have y all by itself, so if I took the square root of both sides, I would get plus or minus the square root of 7 minus x squared. And you see how there's going to be two different really functions. There's a square root of 7 minus x squared, and there's a negative square root of 7 minus x squared, which is going to cause two different y values for the same x. So this is not a function, not a function. And I thought, well, let's just graph some functions and let's take a look. So I have saved a Desmos file for you. I'd like you to open that up. We're going to look at a more complicated graph here in just a second. And my more complicated graph allows me to kind of move an x value along the x-axis. And you can see I'm only getting one y value for this expression over here, this function, right? So I have a function for sure. And if I change it in some way, will it change the domain? Will it change the range? And we're going to talk about that, guys. So I'd like you to open up this expression, and we're going to get to that problem right down here where it says, find the domain of this function. See, when it gives us points, it's pretty easy to find the domain. It's just the x values, and the range is the y values. But if it gives us a function with algebra in it, it might be a little bit more difficult to determine what the domain and range are. So when I look at this guy, well, the domain is all real numbers, all right? Because I can go out as far as I want this way, or I can go out as far as I want this way. I'm finding y values without a problem. Let's change the denominator for a second to a -7. Wow, we got some craziness going on here. As I go over here, look at the purple point is going shooting down there off the screen, and then it'll start coming back from the other side. So it kind of like jumped from going down to all the way up here at the top, coming down this way. So this is called an asymptote. So the function wouldn't be defined right in here. It's got some problems with the domain. Why does that happen? Because we can't have the denominator going to 0 in a fraction. You can't divide by 0. So what I'd like you to add in your notes is we're going to start with the set of all real numbers. We're going to kind of like assume any x value works. And then if we see a fraction, we're going to exclude numbers that make the denominator equal to 0. Okay? So when we looked at this fraction, when we had our first problem, we had a plus 7 down there. There's no way the denominator is going to go to 0 because when you square a number, it becomes positive. And then you add 7 to it, it's always going to be positive. So in this problem, my domain is all real numbers. Okay, so it's going to look maybe something like this. The domain is the set of x values such that there'll be x and then a little bar. And then they might have this symbol, all real numbers. It's a fancy little r. Okay. If I was doing this problem where there's x squared minus 7 down there, now what I would do is if I change this problem, let's say this wasn't x squared plus 7, but it was x squared minus 7 in the denominator, then I would have something like this. X squared minus 7 needs to be not equal to 0. So if I add 7 to both sides, I get x squared cannot equal 7. If I take the square root of both sides, x cannot be plus or minus the square root of 7. So I would change this domain to something like, okay, x such that, that's what that little bar means right there, and then you're going to have x not equal to square root of 7 and x not equal to negative square root of 7. All right? That's how you do these domain problems. Thanks for watching. I think I'm going to make a video 4 for problem number 13.